Hello, welcome everybody. Welcome to this short and quick YouTube video on how you can use Arduino with Python. So today's goal is to basically just make an Arduino project only using Python. So that is we write code in Python and it automatically deploys it onto the microcontroller without us touching a single line of C++. That is the goal. And that's thanks to Reduino. Reduino is a new Python package that lets you write code in Python, which then compiles your written code into C++, and it also automatically deploys it on your behalf. As a full disclaimer, I am the author of Reduino, so I just wanted everything to be transparent that this is my library and this is also me giving an insight to people on how you can use it for any of your projects. But more on that later. So, um, I have a simple circuit design here. I have an Arduino, I have an ultrasonic sensor, a buzzer, and an LED. So we're going to be trying to make a parking system. It's a very classic Arduino project where you have an ultrasonic sensor, and if it detects something less than a certain threshold, the buzzer starts beeping. As an additional actuator, I've also added a green LED. So what this LED will do is it will imitate the distance. So like if the distance between the object and the sensor is way too high, the LED will be really dim. But if we bring the object closer to the sensor, then the LED will start glowing brighter. So that's the goal. So we have these two actuators and an ultrasonic sensor. I'll just quickly go in how it's connected. Of course, the VCC and ground are connected to VCC and ground. The trigger pin is connected here at number 6. The echo pin is connected here at number 7. We have an LED which is at number 5 and a passive buzzer at number 4. I already have wired the circuit in real life as a proper hardware as well. So once we write the code, we will also visit and see what that looks like after you write your code. All right, so here we go. First steps first, you need to install Reduino and you need to install Python. So I am assuming you all can easily install Python. It's not very difficult if you don't already have it. But let me show you how you can install Reduino. It's pretty simple. You just go and open a terminal or a command prompt, and then you can simply type in pip install Reduino. So this will maybe take some time for you. I already had downloaded it once, so it should be cached for me. You can see it says downloading Reduino 1 and it's done. So the second thing you need to install is called platformio. And you only need to install this if you want to do automatic uploads. And I think it's a very cool thing that you can just, run a Python file and it automatically uploads it to the board. So let's just go ahead and type in pip install platformio. Platformio, okay, that should be it. So this is going to go ahead and install another package that lets Reduino upload code directly to microcontroller without you having to manually upload it. All right, and that's basically done for the installation part. All we need to do is basically start coding. So the first thing first, we need to import some things, right? So first things first, we're going to import target. It's a function that is inside Reduino. So from Reduino, import target. And my interpreter can't find Reduino, seems like. I think I need to switch the version. Let's try. Yep, that should fix it. Yeah. All right. So target is basically a function that tells Reduino that this script needs to be compiled into C++. If you do not import it and use it, your script wouldn't be compiled or uploaded. All right. So let me show you how we use it. Just go down here. We'll call target, and we have to pass in a string. The string is your device, your Arduino device. So how do you find out what the name of your device is? On Windows, it's pretty simple. You can just press Ctrl Shift S and it will open a device manager or, oh, this is a task manager, my bad. You just open a device manager, like, let's open, yep. Under ports, you can find your USB serial device. In this case, this is my serial device, which is my Arduino Uno, and it's at COM4. If you're using Linux, you have a different way to know what your device is. It's something like dev slash whatever your device name is. If you are using Linux, you already know what your device name is basically. So let's go ahead and put in COM4. So this basically tells, hey, I have an Arduino for which I need to compile some code and upload it, and it's present at COM4. Pretty cool. So let's get back to the sketch. We have an ultrasonic sensor, a LED, and a buzzer. So we need to make imports for those as well. So I'm going to go from Reduino.sensors, import ultrasonic. So this is our ultrasonic sensor. And for LED, we'll go from Reduino.actuators, import LED. And we can also import buzzer because both of these are actuators, which are under Reduino.actuators. So that's it for the imports. Let's start writing some code. Firstly, we need to define our ultrasonic sensor. So that's simply US equal ultrasonic. And we have a trig pin, right? So if we go back here, our trig pin is connected to 6 and echo is connected to 7. So we only need to pass in these two pins, just like this. Perfect. Next things next, we have LED. So we have simply this, and our LED is connected to number 5. So just pass in that. And finally, we have a buzzer. So our buzzer is connected to number 4. And that's how you just define all your sensors and actuators. From here on, it's pretty simple. We'll just do a while true loop. So those of you who have already used Arduino know that there's a void loop, right, as a function. And anything within that function keeps getting repeated. Like it's like a continuous loop of, and those lines of code keep getting executed again and again. So while true loop is a equivalent version in Reduino. So anything that you write within while true loop will be placed inside the void loop in the compiled C++ script. All right. So I'll just simply say, hey, this distance is equals to us dot measure distance, and we'll go. We also need to import another function actually from Arduino dot utils. We will import something called map. So a map is a simple function that lets us map a value from a certain range to another range. So I can just go here and I'll write mapped equals map. We want to map this value of distance because my setup is on my table. I think the maximum range I will get is 20. Like so, I will specify my range as 0, 20. All right. So when my object is really close to sensor, that is when it's 0, I want my LED to be the brightest it is, which is at 255. Sorry, I forgot to mention that this mapped variable is for our LED because the ultrasonic sensor gives distance within various ranges. I think it's like 0 to 400, but our LED just accepts values between 0 and 255. Hence, we are using the map function. All right, so when the object is really close, like at 0, we want the LED to be its brightest, which is 255. And when our object is like 20 centimeters or more than 20 centimeters, we want it to be completely off, so that's 0. And we can simply write LED equals um, LED. Actually, we can just do LED dot set brightness, and I'll pass in mapped. So what this will do is this will map a value from a distance and set the brightness for LED. We also want to make our buzzer beep if the distance is less than something, some threshold. So let's write if distance is less than, yeah, 10 is a good example. Then we want to do something. Instead of just playing a buzzer, let's play a melody. So Reduino offers these melodies. A melody is basically just a different tone that's automatically coded in the background, which are useful. For example, let's just go here and we can have a look. You can see there's like a success melody. So if you just pass in success, it will like have a nice success type of um, ring to it. This error, this startup, this notify, alarm, all these things. I think for our use case, notify is pretty good. So we are saying, hey, if the distance is less than 10, let's just play notify. All right. Um, yep. And that's it. I don't want to do anything else, right? And this will automatically turn off after playing the melody. Yep. So all you need to do is now to upload it to your microcontroller, and that's pretty simple. You can just run this code. So I'll just go run Python file in terminal, and you see this is platformio. It's doing a lot of compiling. So first Reduino compiles the code from Python to C++, and then we are basically giving this C++ code to platformio, and that platformio compiles that C++ code and uploads it for us. So you can see it was all automatic. You didn't have to do anything. So it says it's successful and it's done. All right then. Um, I'll see you in real life. All right, so here we are. This is my Arduino development stack, and it has a green LED, a buzzer, and an ultrasonic sensor, as I showed at the start of the video. It's wired in the exact same way, and we should probably just test out what it's like, right? So I'm gonna put my hand somewhere here, like this, and I'm gonna move slowly. Okay, so around at this point is the 20 centimeter distance. So like this is lesser than 20, this is more than 20. Cool. So I'm gonna bring my hand slowly closer, and you can see like the LED is getting brighter, and if I bring my hand farther away, it's getting dim. Cool. Also, when I bring my hand really close, less than 10, you can listen to that notify melody that's being played. Super cool. We did not have to write a single line of C++ for this. Everything was just in Python. It was then compiled to C++ for us. So yeah, pretty cool. All right, let's get back to the code editor and we'll see how it actually works. So here we are after the demo, and I think it's time we actually peer inside and see what's happening behind the scenes. I think it's a thing to know what actually Arduino does. So I'm gonna come here and I'm gonna set my upload variable equals to false. This instructs Reduino that, hey, I just want to transpile my code, but I do not want to upload it to my MCU. So it's just a preventive measure. It's not mandatory, but anyways, and I'm gonna wrap this entire line inside a print statement because this target function, it actually returns us something. Let's see what happens. I'm gonna go here and run the file, and we have a long code here, right? So this is basically, if you didn't already guess it, a compiled C++ code that's being generated by Reduino. So all your Python code, which is here, is transpiled into this huge, enormous C++ code. And then this code is basically sent to platformio and it compiles it and uploads it. So you can already see the read ultrasonic measure function. So those of you who have used ultrasonic sensors, you have to actually manually write the logic for getting the distance, but Reduino does it for you here. If you scroll down, you have a void setup function where all the pins are initialized, a void loop function, which is basically uh, our while true function. So, yep, pretty cool. This is the code that's generated in the background. All right, so let's just have a look at the GitHub page for Reduino. I made the first release about 16 hours ago, and I wanted to quickly make this video so anyone who's looking for a good solution on how you can use Python with Arduino can have some sort of resource that they can use to, actually make useful projects, useful and cool projects. So as of now, Reduino is pretty limited um, in what it can support and what it can do. For example, there's LEDs, you can do all these things, which is super cool. There's RGBs, there's buzzers, there's some things, but of course, there's not everything. So, for example, if you wanted to work with a temperature sensor, the support for that isn't on Reduino as we speak. But the good thing is, because I am the developer, I do want to continuously keep updating it. I want to keep updating Reduino with more sensors and more actuators and basically turn this into a full-fledged library. Um, I think it would be pretty awesome if you could also, um, if you also want to contribute to the project, there's like a nice contributing guidelines on how you can do it. Otherwise, if you just use Reduino, that's also super cool to me. And if you ever face any issues, if you have like bug, please always just go to issues and open the issue, maybe with a code example and preferably with a image of your setup. It would tremendously help me because I'm just a solo developer. So any sort of input that I can get from people, any issues that I can get from people that they're facing, I think it's pretty useful for the development of this open source project. But yeah, that's what I wanted to share with you. All right then. So I think that's it for this introduction to Reduino and how you can use it to make your own cool Arduino projects using just Python. So that's it from my side, and bye bye.